In this video, I'm going to wander around in CLion so that we can explore how structs actually work in C. So we're going to look at some code, and then we're also going to look at how they lay out in memory. So the purpose of a struct is to allow us to package a bunch of different pieces of data into one thing and treat it as one data type. So as an example, here I have declared a struct whose name is 3 things, and it contains 3 integers that I have named 1, 2, and 3. So this creates a new data type whose name is struct 3 things. Since I have that data type, I can declare a variable that I've named data, whose type is struct 3 things. That means that data now contains 3 integers. I can use the dot operator to access each field. So here I set its 1 field to 42. I set its 2 field to 43. And I set its 3 field to 44. Let's watch that in a debugger, see what happens. So when I stop, I can look, here is my variable named data. It knows its type is struct 3 things. And it has in it 3 fields, 1, 2, and 3, and they have the values that I gave them. If we go to memory view, we can look at how this looks in memory as well. If I dump the stack, so the stack pointer is right here, so I know the stack frame is below that. I don't know how far down it goes, but I know it's below that. And I'm looking for the values 42, 43, and 44, which in hex are 2a, 2b, and 2c. They are right here. And you can see that what it's done is it's made one contiguous piece of memory that has all of the parts of data. So when you have a struct and you allocate something to be of that type, it gets enough space to hold all of those things as one contiguous location. For my second example, I want to show you a struct and actually some processing on the struct, and we're actually going to look at arrays of structs. So for this one, assume that I have a team of players. For each player, I have a name and their score, and my goal is to figure out who's the best player. So for each player on the team, I need to hold a name and a score. So I made a struct, person T, and it has a character array that is the name, and there are 8 spaces in that, so we can have names up to 7 spaces long because I need the null terminator on the string. And then a score that is an integer. With that declaration of struct, I can declare an array whose name is team, whose type is struct person T. So each entry in team is going to be a struct person T. And then I've used an array initializer to fill in that array. An array initializer has curly brackets around the end. And then because it's a struct, we have curly brackets around each entry within that struct. And then the rule is that you put in the values for each field in the order that the fields were declared in the struct. So when I declared the struct, I said name was the first field and score was the second field. So this will create one struct that has Henry for the name and 41 for the score. The second entry in the array will be Fred with a score of 16, and so on and so forth. Now, if you remember, there are 2 ways in C that you can know how long an array is. One is you can hold a value, that is how many things are in the array. The other is you can put a flag entry at the end so that we know that we hit the end because we run into the flag entry. So for this example, I have created a flag entry that is a struct that has the name end and the score -1. So if I run this in the debugger, you can see here we have a team, and the 0th position is Henry with his score of 41. Then there is Fred with his score of 16. And so on and so forth until we get to the last one, which is end with a score of -1. And if we look at the memory view of that, look at, it's all going to be in the stack because it's a local variable. The memory view helps us because over here it's showing us if those values were ASCII, what would it look like? And so that makes it really easy for us to find the names in our array. So you can see here is Henry and his score of 41, which is 29 in hex. And then Fred and his score of 16, Liz and her score of 40, Merlin and my score of 42, yada, yada, yada. Eventually you get to end with a score of -1. So when you have an array in memory, it's always the entries, one right after the other. If those entries are structs, there's enough space for the struct and then enough space for the next struct and so on. So with that as how it's laid out in memory, let's think about what the machine has to do to find index 4 of that array. Each entry is the size of the struct, and that is 12 bytes long, because it's 3 words, 4 words and a byte, 12 bytes long. So index 4 is going to be 4 times 12 bytes past the beginning of the base address. So if we go back to here and say disassemble this code, we can look at the actual machine code that is being generated, and because I've clicked on this, it's highlighted over here. So the first thing this colon printf is going to do is do the index team by 4. So this 50 bytes before the base pointer, that's the address that is the base address of the array. That's where the array starts. And then it adds 30 in hex to that. Well, 30 in hex is 3 times 16, 48, which is 4 times 12. So the first thing that I want to do with that array is make a function that will give me the player who has the best score. So I pass in the team and it returns to me a struct person T that is the person with the best score. So it ought to return me because I have the best score of 42. This is going to be a standard Sentinel controlled loop because I'm going to walk through the array searching for that score of -1. And I'm just going to look at each value in the array. I'm going to have a struct that is holding the one with the best score that I've seen so far. And as I walk through that array, if I see one that is better than the best one I've seen so far, it's the best one I've seen so far. When I get to the end of the array, the best one I've seen so far is the best one. So if I code that, thinking of it like it's an array, I get code that looks like this. I've passed an array. I take the 0th person in the array and I store it in my result, which is the best thing I've seen so far. And then I'm going to use an index I to walk through the array. So you can see I here, and I gets bigger by 1 each pass through the array. And the loop is going to go until I find that score of -1. So that's my Sentinel controlled loop. And at each position, if the thing that I'm looking at is better than the best one I've seen so far, it becomes the best one I've seen so far. So let's watch this run. So I'm here, and you can see people is the name of my array, and I can only see one of them. Well, the whole array is actually there, but when we pass an array into a function, we don't pass the whole array into the function. It does not make a copy of the array and pass it in. Like when we pass in an integer into a function, it makes a copy of the integer and puts it in the variable. When you pass an array into a function, it gets turned into a pointer. So people is a struct person T pointer, even though it looks like it's an array. But that's okay. When you have a pointer, you can pretend like it's an array. So we can index it like it's an array. That'll be fine. So I step over this. I've now stored the 0th one, which was Henry, into result because that's the best one I've seen so far. And then I look at position 0. Is it -1? No, because that's not until we get to position 5. Compare these two. Okay, so my problem here is now I is 1, but the debugger just shows me the first one. So it's really hard for me to debug this because people sub I have to think about, well, that's people 1, that's Fred, that has a score of 16. That's not better than 41. Okay. Do it again. Now what is people sub 2? Well, that's Liz, but the debugger isn't showing me that. I have to go find the declaration of team. And if team wasn't a hard-coded team, if team was something we had calculated, it's really hard to debug this because I can't look at what is in the ith entry of people. And the core reason that that is the case is because people is actually a pointer. We're pretending like it's an array because we're comfortable with arrays, but people is really a pointer. So, you know, I can run this to the end and see that it did find Merlin. So this works, but it's really hard to debug. So what I'd like to do instead is treat team like it's a person. So I want to make the exact same function, but instead of treating the parameter like it's an array, I want to agree with it that it's a pointer. So that's what this find best with pointer is going to do. So I'm passing in, now I've admitted p_person is a pointer to a struct. I'm not pretending that I'm passing in an array. I'm passing in a pointer to a struct. I called it the same way I called it before because passing an array actually passes a pointer. So the first thing that I need to do is the best thing I've seen so far is the 0th thing. So this line will chase p_person because it's a pointer to a person and get the struct that it's pointing at, and it will copy it into best so far. So you'll notice best so far is a struct, and so you see the name and the score right there. p_person is a pointer, and so you have to chase the pointer to see it. Now, to have a pointer that walks through my array, I'm going to copy p_person into it, and then that's the pointer that I'm going to move because I don't want to move p_person because it's a pointer. So line 16 is going to create a variable whose name is cur, whose type is struct %t pointer, and it's going to copy p_person into it. So if I watch that, now cur is a pointer, and its address is the exact same address as p_person, so of course they have to be looking at the same things. There's Henry and school. So the first interesting thing to me to pay attention to is line 15 and line 16 are essentially the exact same statement, but I put the asterisk in a different place. So both of them declare a variable and use it in an assignment statement. In the first one, the variable that I declare has a type struct %t. Since p_person is a pointer to a struct %t, I have to chase that pointer to be able to put stuff into best so far. That's why the asterisk is at p_person. In line 16, I'm declaring a variable whose name is cur, whose type is struct %t pointer. So cur is a pointer just like p_person is a pointer. So when I do the assignment to put p_person into cur, that's copying the pointer, not the thing that it's pointing at. Okay, so then our while loop starts, and we can look at cur. Does cur have a score of -1? No. So we can look and compare the score of cur to the score of best so far, not greater than, so we don't copy things over. Now we're going to increment cur. When I look at that, the first thing I think is it's going to make cur get bigger by 1. Well, that's going to be really terrible, because if I just make cur get bigger by 1, it's going to point at the E in Henry, because it's just going to move 1 byte over in memory. But when you do arithmetic with a pointer, it does not increment by 1 byte. All of the math is done in units of the size of what it's pointing at. So cur is pointing at a struct person t. So when we increment cur, it gets incremented not by 1, but by the size of struct person t, which we already figured out was 12. So when I step over this, you'll see it goes from 5a0 to 5ac, where c is 12. C in hex is 12. It added 12 to cur. And so now it's pointing at Fred, whose score is 16. That score is not -1, so the loop keeps going. Now we can compare the score of cur to the score in best so far, and it's not better. As a pay attention to the details, we had to use the arrow operator to get the score out of cur because it's a pointer. We had to use the dot operator to get the score out of best so far because it's the struct itself. Not greater than, increment cur. Now cur points at Liz and her score of 40, still not better than. Increment cur again. Now it points at Merlin and my score of 42. It is better. So now it's going to chase cur to get this struct and copy this struct into best so far. Now best so far has Merlin and my score of 42. And so this is walking through the array the same way the index version of was, where we say that sentence again. This is walking through the array the same way that the one that we indexed was walking through the array. But now I can see what I'm looking at every time because cur is walking through the array. And so I can see what exactly is going on in these comparisons. It's easier to debug this than it was when we couldn't see what was people by. So while pointers to structs are not the thing that you're most comfortable with, if you can get comfortable with them, they're much easier to use than pretending like the thing that you passed in was an array. So just to finish the game here, best so far ends up being Merlin and everything works. For my third example, I want to show you how you put structs inside other structs and some motivation for why we would do that. So imagine that you want to keep information about all of the vehicles that drive on our roads. Passenger cars, 18-wheelers, campers, all the things that are on our roads. There are some things that are common across all of those kinds of vehicles, and I'm going to call them engine stats. So, for example, all of those vehicles have a horsepower, and all of their engines have a volume to them. So I can make one struct that contains all of the common things. In this case, I've called that struct engine stats t, and I've put those in there as integers, horsepower and volume. Volume is normally a real number, but this is going to be easier for us to see in memory how things are laid out. So if I have that struct, then I could make a struct that kept all of the information about a particular passenger car. It has engine stats, so its first field is a struct engine stats t field that I've named stats. And then its second field is an integer that I've named number of seats. And with that declaration of the struct, I could create a passenger car, the X1, and an X1 has 5 seats, so I've used the dot operator to put 5 into its number of seats field. Then its horsepower is 241, and so to set its horsepower, I have to do x1.stats to get to its engine statistics, and then dot horsepower to put the horsepower into it. And similarly, I need to use 2 dot operators to store 2 into the engine volume. But if I debug and stop right there, we can see, oh, I debugged the wrong thing. Whoops, sorry. Let's debug the right thing. There we go. X1 is a struct passenger car. It has a struct engine stats T of stats that has the horsepower and the volume, and it has a number of seats that is 5. And if I were to look at that in the stack, we can see here the 241, the 2, and the 5. So this part is the engine stats T struct, and that's the number of seats in the passenger car. Even though to us it feels like one's like inside the other, when it gets put in memory, it's just flattened. They're just 3 things, one in a row. And we could have declared it that way, but I'm going to show you why it's better that we pulled out the common things into one struct. The next thing I did here was I made a variable named pointer whose type is pointer to a struct passenger car, and gave it the address of x1. I'm trying to verify that this part of the memory that I think is that x1 struct, I want to make sure that it is. If I step over this, pointer now has the value E5C4. And in my memory view, E5C4 is right here. So the address of my struct is this. So that really is where it was supposed to be. So if I want to take the address of a struct and store it into a pointer, I can do that. All right, so in addition to passenger cars, our highways have 18-wheelers on them. So I've called them big rigs. They also have engine stats. So I've given it a field named stats, whose type is struct engine stats T. But then for 18-wheelers, we also keep track of how much weight they can carry in their back and whether or not they are a sleeper. So does the cab have that camper ability for the driver to comfortably sleep in? And with that, I can declare a variable whose name is Mac, whose type is struct big rig. I can set its horsepower and volume the same way I did for the x1, using 2 dot operators, one to get to the stat struct and one to get to the field within the stat struct. And then I can set sleeper and load capacity directly. And if I step over all of that, now we can see here's the load capacity, the volume. Do them in the right order. There's the volume. 15 is the order. 4 is the horsepower. So horsepower, volume, load capacity, sleeper. Those 4 are the big rig. Now, there are a couple of reasons to do this. First, if you look at the declaration of the structs, the thing that's really nice about this is if I decide that I need to track one more engine stats, I only have to add it to this struct, and these guys will automatically get it by default. So that's the first thing. The other thing is, if I want to pull out just the engine stats from one of these things, it's really easy to pull out just the statistics that matter when I'm the dude who pays attention to the engine. So for example, I can make a function comparing 2 sets of engine stats. So I can make this function named first engine has more power, and you pass in 2 structs. Each of them are engine stats structs, but you pass in 2 of them, and then you can compare them. So I can pass in x1.stats and mac.stats. And this function doesn't know that the first one is from a passenger car and the second one is from a big rig. It doesn't care. All it's doing is comparing the engines. And it can make the comparison. So, I mean, comparing their horsepower is a little silly, but we could do all sorts of, we could output an output that was the comparison of all of the engine statistics. the point is that we pull out that engine stats T struct, and now it no longer matters whether it came from a passenger or it came from a big rig. The way that I get to horsepower and volume is the same, no matter what vehicle it came from. So, bottom line, you can put a struct inside a struct, and we often put a struct inside a struct. And we do that for two reasons. The first is by being able to reuse the inner struct, that engine stat struct, we can have the same thing in multiple other structs. And then if engine stats changes, it changes for everybody. And the other reason is we can pull that data out of each of the other structs and access horsepower and volume the same way, no matter whether I was looking at a passenger car or a big rig. Thanks for watching, and I hope that was a useful examples of structs. Please like and subscribe and ask me any questions in the comments. Thanks.